Hey everybody, what's up? It's Coach Sharf. Welcome back to my video notes for our Algebra 2 lessons. Today we are going to talk about using synthetic division to divide polynomials. So again, we already talked about long division. You know, if you're seeing this with this class in real time, that link is also included in your assignment on Canvas. If not, you know, if you look at the uploaded videos on my YouTube channel, it should be the video right before this. But today we're going to focus on synthetic division. So let's get started. So pull up active board. All right. So again, if you're continuing your notes that we've had for a long division, you can either make this kind of like a subheader in the middle, or like I said, you know, when I would take notes, if I would kind of start a new topic, I would, you know, put it in the margin on the right-hand side of the page and then just continue. So we're going to have one little quick blurb about what synthetic division is. Then we're going to go through the steps. I have 6 steps listed out. I'm going to kind of explain the first problem. I'm going to go a little slow with that as I go through the steps, but with the rest of them, I'm going to pick up a little bit of speed. There's 4 more examples after that. Last couple are pretty similar to this. Or first couple extra examples. So examples 2 and 3 are a little similar to this. The last couple have some tweaks in them, but we still do the same process. All right. So with synthetic division, we ignore the variables. I put that in quotations. So as we're going through the process, we're only looking at numbers. We're not completely ignoring the variables, because at the end of the problem, we bring the variables back in, because again, we're dividing polynomials. Our quotient is still going to be a polynomial. So, you know, we're still going to get some kind of polynomial as our final answer. But during the process, we're ignoring the variables. You know, most of the time it's going to be x's, but whatever you got. Only looking at coefficients and constants. The divisor, the thing you're dividing by, must be x plus or minus a constant. You can't have a coefficient or an exponent on whatever your x is, your variable is. You know, if it's a different variable. In reality, you can actually do it if you had a coefficient. So, you know, 3x minus 5 if you had the 3 out in front of x. It's trickier though, and we don't need it for the task that's coming up going forward. So we're not going to waste time on it. So you could do it with a coefficient in front of x. Like I said, you know, it changes up the process a little bit and is unnecessary. You know, it's unnecessary for what we're doing. But you can't do long division regardless if your x has an exponent. So if you just had x squared minus 3, or, you know, a full quadratic, 2x squared plus 6x plus 21. You can't do synthetic division with that. You would have to do long division. And even for our constant, again, we're going to stick with constants that are whole numbers. You still could do this if you had a constant that was a fraction. Again, it's just going to make the math a little more difficult, because you're gonna see at some point we're multiplying by that constant, which we'll get to in a little bit. So if you're multiplying by fractions, it gets a little tricky. So you could do this even if it was a fraction or a decimal in theory, but we're just gonna stick to this being a whole number. So x minus 2, x plus 5, things like that. All right, so go ahead and jump into step 1. So we're going to use the same example from log division. Again, I put it in parentheses. The first step actually starts here, but we're using the same example that we used for the steps for the long division notes. Again, go back and look at that if you need to. That example is x cubed plus 9x squared plus 26x plus 24 divided by x plus 2. And for starting synthetic division, it doesn't matter if it's written horizontally with the division sign in the middle, if it's actually written like a fraction. So if you had x cubed plus 9x squared, yada, 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 over x plus 2, or even over here written like a long division problem. You know, when we're doing long division, if we get either one of these, we want to turn it into this. With synthetic division, we can start with any of the 3, because the way we do synthetic division, as y'all see, it doesn't look like any of these. So whatever way it's presented to you, you start, you're going to list the coefficients and constant from the dividend. Again, the dividend is the thing you're dividing into. So your first term here, your numerator up here, and not first term, your first polynomial, excuse me, here, your polynomial in the numerator here, and then your polynomial that you're dividing into here. So we've got x cubed, which has that invisible 1 in front. So 1x cubed, so we're going to put a 1. 9x squared, we'll put a 9. 26x, the 26, and the 24, we put the 24. So this is what we're starting off with. Again, you need a little space between the numbers. Don't cram them in there, okay? Again, if you need to pause this to finish writing this, that's fine. But like I said, I'm not trying to have a 30, 35, 45-minute video, so I'm going to go. All right, step 2, draw an L, leaving space under our numbers. So to the left of our numbers, we're going to start here. We're going to come down, then come all the way across, drawing a L, leaving that space. Again, you can almost kind of think of it like we're taking the division symbol for long division and flipping it upside down almost. If you want to, if you want to try to tie it into this again, this is kind of I'm going to show you how it ties into mathematical processes we know. Again, it's a little, I don't want to say convoluted, but kind of one of those workarounds, a shortcut, if you will, that makes sense. But like I said, it's not it's not an original true mathematic process, but it works. So there's that. All right, step 3. So first thing is, again, we're just writing what's in green and the little bit of red here. I'm going to use this to explain some stuff in a second, but you don't need to write it. But you need to, again, listen to the explanation so you know why we're doing something specifically. We're going to make the box on the left of the L, left of the coefficient. So the left side of the L up here on the left of the coefficients, we're going to make this little box, okay? We're going to put in the constant from the divisor, but with the opposite sign. So we're going to put in, we're going to look at x plus 2. We're going to use the positive 2, but we're actually going to give it the opposite sign. So we're actually going to use negative 2, and that's what we put in here. The idea behind that is it kind of ties into this. Again, there's a couple ways where you can say where it really pulls from, but looking at a different polynomial, in this case, just quadratic, x squared plus 7x plus 10. I know that's pretty sloppy and you can't read it, but just trust me that it's x squared plus 7x plus 10. If we factor that, it's x plus 2 times x plus 5 equals 0. So those are my factors. Again, listen to my terminology here, because this is what we're going to be doing the next couple weeks. Those are my factors. So I'm working on finding my factors, but I'm also working on finding the roots / zeros. Remember the roots, I'm trying to figure out how to get that together. Roots / zeros. There we go. Remember, roots and zeros are the same thing. So, we'd set your factors equal to 0, x plus 2 equals 0, subtract 2 from both sides, x equals negative 2. So it's kind of that reasoning, okay? So again, I'm already going to tell y'all that x plus 2, and again, if you remember from your log division, we know x plus 2 is a factor of this because it's going to divide evenly. So, when we get the negative 2, another way to kind of check it is, and again, we'll talk about this a little more next week. You can actually plug the negative 2 into all of this. X cubed plus 9x squared plus 26x plus 24. So if you plug in negative 2, work it out your math and get 0. Again, that means that negative 2 is a 0, is a root, because I plugged it into my equation, my function, and got 0 as the answer. So that's what, that's how the negative 2 kind of ties into that. All right, step 4. We're going to drop the first coefficient under the L. It's supposed to be a quotation mark. Again, I know it kind of looks smudged. There we go. Under the L. So we take the 1, drop it down. We're going to take that coefficient, the 1, and we're going to multiply that coefficient by the number in the box. So we're going to multiply it by this -2. So I've got 1 times -2 in parentheses, which is -2. And then I move that -2 under the next coefficient. So 1 times 2 is -2, and I move it underneath the 9. You can pause here to get this written down and rewind it 30 seconds to hear it again, but I'm moving on because, like I said, I'm trying not to have it too long of a video. So after I move that -2 over, I'm going to combine like terms. 9 minus 2 gives me 7. The 7 I now have, again, I'm going to multiply by the number in the box again. So 7 times -2 is -14. I carry it over under the 26. And now, at this point, we're just repeating the same thing over and over and over again. So 26 minus 14 is 12. 12 times that -2 is -24. 24 minus 24 is 0. And since this is my last number up here, I stop. I don't have to worry about carrying it on any further. Okay. So again, you just write what's in red. It's just that I began the slide. Just write what's in red, but again, I'm about to show why what's in white makes sense. So pause it if you need to write the finish writing this in red real quick, and then I'm gonna show you how they tie in. So if you look, ignoring this first x cubed minus x cubed, I got 9 minus 2 is equal to 7 right there. Again, this is when I did the long division. Go back, look at your long division if you need to. 9 minus 2 equals 7. Got it right there. Okay. 20. I'm supposed to change the green. Sorry. 26 minus 14 is 12. 26 minus 14 is 12 right there. And then 24 minus, I'm going to go a little further out. So 24 minus 24 is 0. I know it's kind of hard to see. 24 minus 24 is 0. So those all match up. Again, it's the same idea about this is our remainder and we divide. The 0 is our remainder. It's the same thing here, which we'll talk about a little more on the next slide. And then the last thing for y'all to kind of notice is if I look, again, if I put the invisible 1 here, I've got 1, 7, and 12 up there, even though they have the X's on them. 1, 7, and 12 down here. So those all match up. And again, I'm going to tell y'all how we turn this into this on the next slide. So let me back up. So all that's gone. So I don't got to worry about it next time. All right. So slide 6, step 6. Again, ignore the white for a second. Just do what's in green and what's in purple on the end. So we're going to cut off the last number as the remainder. So that's 0. And you make its own little box, kind of cut it off from the rest. That's your remainder. I'm going to show you on one problem, on one of the examples, what to do when you actually have a remainder as far as how to write it, which I kind of might include as a bonus on, the next quiz. Like I said, if we'd had a little more time to go in depth on it, we would have, but I don't necessarily need y'all to know how to write the remainders for this, because it's not about how to write a remainder. It's whether or not your remainder is 0 or not. Again, you'll see what we do next week when we're doing our synthetic division. If our remainder is 0, this number that we used over here worked. And again, y'all will see next week, what I mean by it works. If this remainder is not 0, then this number didn't work. And I got to try to find another number to do my synthetic division process with until I get a remainder of 0. But again, we'll worry about that more. Again, if you're doing this in real time, next week, if you're looking at this in the future, in terms of your videos, should be the next video. I honestly don't know how I'm gonna do the next video because I have a packet of tasks I always like to use from the state website that I'm gonna do the next couple weeks. So, might just be me making a video of me going through that packet. I'm not sure, but anyway. So woohoo. Sorry, guys. It's one that catches about trying to record this during school hours with the announcements coming on. Anyway, so cut off that last number as a remainder. Okay. Then as we go left from that number, let's go back to the left. We're going to label them underneath the numbers counting up. So we're going to start with our constant. So you start with, your first number is constant. Then you label the next number x to the first, x squared, x cubed. However far you got to go up, or really it's going to the left. So however far you got to go up. Okay. So 12 is a constant. 7, I label x to the first. 1, I label x squared. And again, that's as far as I'm going to go. So again, 12 is my constant, but then, for x to the first, x squared, x cubed, so on, so on, so on. These are going to be my coefficients. That's why I was still calling them coefficients earlier, because, they still wind up being coefficients for your final quotient. So I have 1x squared, which I can just write as x squared, 7x to the first, which I can just write 7x, plus 12. That's my quotient. So again, when I divide x cubed plus 9x squared plus 26x plus 24 by x plus 2, I would get x squared plus 7x plus 12. All right. So we got 4 more additional examples we're going to do. Again, the second one I did in class, I think, for pretty much everybody. And again, this is one of the examples that I did for long division. Again, just showing you, you get the same thing whether you do long division or synthetic division. So first step, I got to look at my dividend, the thing I'm dividing into, write out the coefficients and the constant. So 2, -3, -17, -12. Step 2, draw my L. Step 3, put my box outside my L. And I'm going to put in a box the constant of my divisor. So the constant of the thing I'm dividing by, but with the opposite sign. So I'm not going to put -4, but I'm going to put +4. And again, you can just put it as 4. You don't have to put the plus sign. Okay. And then we just start the process of long division. So again, there's only this one number. So, I don't have the second number underneath yet. So this 2 is going to drop all the way below. Then I'm going to carry it to the next column while multiplying it by 4, which is going to give me 8. So again, that's step 4 to start the process. Step 5 is to combine like terms here and then just repeat the process until I can't do it anymore. So -3 and 8 is +5. Move it to the next column while multiplying it by 4 is 20. -17 and 20 is 3. Move it to the next column while multiplying it by 4. -12 and 12 is 0. All right. So I've gotten to my last number. Again, when I do my math here, this is 0, which is key. So I have a 0 for a remainder. So then again, looking at, maybe you want to do this in different colors just so you don't, get confused by the 4s and parentheses, but 3 is my constant. 5 goes on x to the first, 2 goes on x squared. So when I divide 2x cubed minus 3x squared minus 17x minus 12 by x minus 4, I get 2x squared plus 5x plus 3 as my final answer. All right, example 3. Got 3x cubed minus 2x squared plus 2x plus 7 divided by x plus 1. coefficients and constant of my dividend, 3, -2, 2, 7. I did this one in my head. I didn't test R. I hope I did this right. I think I did. I did. Yeah. Sorry, I was second guessing myself real quick. So write your coefficients, write your L, put your box. We're going to fill it with the constant of our divisor, but with the opposite sign. So not +1, but -1. Okay. Now I'm going to try to change up the colors a little bit. So bring down to 3. Then I'll go back to blue up here. We're going to bring it, multiply it by -1, which is -3. -2 and -3 is -5. Carry that to the next column, multiply it by -1. -5 times -1 is +5. 2 plus 5 is 7. And then I'm going to carry that to the next column again while multiplying by -1. Okay, I did do it right. So 7 times -1 is -7, and then 7 minus 7, of course, is 0. So again, 0 is my remainder, 7 is my constant, -5 is the coefficient on x to the first, 3 is the coefficient on x squared. So that gives me, again, I'll put it in purple, 3x squared minus 5x plus 7. So when I divide 3x cubed minus 2x squared plus 2x plus 7 by x plus 1, I get 3x squared minus 5x plus 7. So there's example 3. All right, example 4. Hopefully you notice a couple little tweaks here. First tweak is I have -x cubed out in front. Again, you can have a negative coefficient there. And we'll address that in a second. But the bigger thing you probably notice is I have x cubed, x squared, I have a constant, but I no longer have x to the first here, okay? So, yeah, we really didn't address this for long division, but either way, for long division or synthetic division, if you're missing a term, bye, Ms. Belk, have a good weekend. When you're missing a term, okay, you need to put it with a placeholder of 0, whatever term is supposed to be there. So in this case, 0x, okay? So whatever term is supposed to be there, you're going to put it in with a placeholder, okay? So plus 0x plus 9. So if you were to do this as long division, you would have -x cubed plus 4x squared plus 0x plus 9 divided by x minus 3 if you were to set that up for long division. Okay, for synthetic division, again, we're looking at those. Looking at those coefficients, okay? So -x cubed, again, it's like still like that invisible 1 out there. So -1, 4, 0x, you got to include that 0, 0, 9. Okay, draw my L. It's more like an A. Let's make it look a little more like a 9. There we go. Okay, draw my L, put my box, and look at my constant of my divisor, which is -3. So I'm going to use the opposite sign. So I'm going to use +3. All right. Bring the 1 straight down, -1. Move it to our next column, -1 times 3 is -3. 4 minus 3 is 1. Bring it to the next column, multiply it by 3. So 1 times 3 is 3. 0 and 3 is still 3. Bring that to the next column, multiply it by 3. 3 times 3 is 9. No, it's a little slanted here, but I've got 9 plus 9. Again, I just picked a problem from the book. Maybe should have done one where I didn't have 9 and 9 here, because I might get confused and y'all might think it's supposed to cancel out. I did all my math right, so this is still positive 9 and positive 9, which does give me positive 18. Okay, I did all my math right, so it's not supposed to cancel out. All right, so -1, 1, 3, 18. Again, I'm going to cut this off as my remainder. So now I do have a remainder. Again, first time we've really seen a problem with the remainder. So again, in the context of next week, all that means is with me trying to do synthetic division, this 3 didn't work, which means x minus 3 is not a factor of this. So you'd have to try to find something else that is a factor. Okay. But in terms of still trying to divide this, okay, this is still my remainder. I would still kind of do the same thing this last step. This is my constant. This represents x to the first. This represents x squared. So I've got -1 x squared. So I'll just write it as negative x squared plus 1x, which is plus x, plus 3. And now for my remainder. Yeah, I briefly addressed this in a few of the classes. I don't think all of them. So how I'm actually going to write my remainder to include it with my quotient. You know, since this is positive, I'm going to put a plus. If this was negative, I would put a negative sign. I'm going to put 18 in my numerator. And then whatever my denominator was, my divide, or in this case being the fraction, whatever my denominator was up here, whatever my divisor is, so whatever I'm dividing by, in this case, x minus 3, is going to go in the denominator here. So my answer would be -x squared plus x plus 3 plus 18 over x minus 3. That would be my formal correct answer if I was dividing this up here. Again, you know, if you're watching this and get it down, I would keep that in mind on how to write the remainder as that fraction, because like I said, I might include it somewhere down the line for extra credit. So like I said, we're not as concerned on how to write it, but I still need to show it to you. But again, ultimately, you know, what we start next week, I'm really only concerned if this is 0 or if it's not 0. So all right, last example. So now we're gonna, you know, we had a negative leading coefficient on the last one, and we were missing a term. This one's got all its terms. It's just regular old x, you know, regular old x to the 4th with no coefficient, but it is x to the 4th. So, you know, we've jumped up a degree. So now we have x to the 4th power. We do have all, you know, x cubed, x squared, x first constant going down. So we'll still do the same process. All right. We're going to write our coefficients and constant for our dividend. So 1x to the 4th. So 1, -5x cubed, -8x squared, 13x minus 6. Draw my L. Put my box. And in the box, I'm going to put the constant for my divisor, but with the opposite sign. So instead of -6, I'm going to put +6. Again, let's do the process one more time. Start by dropping 1. Carry it to the next column while multiplying it by the number in the box. 1 times 6 is 6. -5, add 6 back, or again, 6 minus 5 still gives me 1. Carry it to the next column, still multiplying it by 6. -8 and 6 combines to give me -2. Carry it to the next column while multiplying it by 6. -2 times 6 is -12. 13 minus 12 is 1. Carry it to the next column, multiply it by 6. 1 times 6 is 6. -6 and 6 cancels out to give me 0. All right. So again, it's still the last number. So this is still the remainder of 0, which is good. It means it divided evenly. Okay. So my constant is 1. -2 is the coefficient on x to the first. 1 is the coefficient on x squared. Still got a number though, so I still keep going. 1 is the coefficient on x cubed. So my final answer, I have 1x cubed plus 1x squared minus 2x to the first, or just 2x, plus 1 as my constant. All right. So got through those examples. Again, hopefully those helped you. You know, again, I hope you're pausing as you went along. If you didn't, again, go back and rewatch and you know, pause as you need to write steps down. You can rewind it to absorb. You know, I didn't, being first week back, I didn't hold office hours this week. They will resume next week. So if you need a little more help with this, you can always come to office hours, because we're, like I said, with the synthetic division in particular, we're you really need to know how to do it. You got to be able to do it for what we're doing the next couple of weeks. So, you know, try to make sure that you get that down as quickly as you can. Other than that, I'm going to end the video. Until next time, guys, this is Coach Scharf, and I'll see you soon.